Have you ever looked at a massive skyscraper or a huge suspension bridge and wondered, how does that not fall down? As civil engineers, we don't just build structures, we build structures to withstand invisible forces. We call these forces loads. If we don't understand and calculate these loads correctly, things break. Today, we're going to break down the basics of structural loads in civil engineering so you can look at buildings in a whole new way. Let's get started. To understand loads, we first have to look at buildings in 3D. A structure isn't just a flat drawing. It has a vertical plane, front to back, a transverse plane, left to right, and the horizontal plane, top to bottom. Forces can hit a building from any of these directions. Let's start with the most obvious one, gravity. These are vertical loads, and they come in two main flavors. First is the dead load. This is the weight of the structure itself. The concrete, the steel beams, the roof, the floors, everything permanent. It's dead because it never moves or changes. Then we have live loads. This is everything else. It's you, your furniture, your dog, and even the snow piling up on the roof during a winter storm. Live loads are temporary and can move around. When engineers design a floor, they have to guess the maximum live load that might ever be in that room so it doesn't cave in during a crowded party. But gravity isn't our only enemy. We also have to deal with forces pushing against the sides of our buildings. We call these lateral loads. But wait, there's more. Engineers also have to calculate soil pressure, the lateral force of dirt pushing against retaining walls or basements. And if water is involved, we deal with hydrostatic loads, the pressure of still water, like against a dam, and hydrodynamic loads, the crushing force of moving water. There are even thermal loads, where structures actually expand and shrink as the temperature changes. So we know what the loads are, but how do they actually sit on a structure? Let's look at a simple beam to understand the three main ways loads are distributed. Number one, the point load. This is when a force is concentrated in one specific narrow spot. Imagine one person standing right in the middle of a plank of wood. All their weight is acting on that one single point. Number two, the uniformly distributed load. This happens when weight is spread out perfectly evenly across a surface. Think of a group of people standing an equal distance apart across that same plank, or the weight of the floorboards themselves. The pressure is equal everywhere. Number three, the triangular distributed load. This is when a load is really heavy on one end and gradually tapers off to zero on the other end. You see this a lot in retaining walls, where the soil pressure is highest at the bottom and zero at the top. On our plank, it looks like a crowd of people bunched up on one side, getting sparser toward the other end. At the end of the day, civil engineering is a massive balancing act. We have to take the dead loads, the live loads, the wind, the earthquakes, and the water, figure out exactly how they are distributed, and then pick the right materials to fight back.